I haven't been sleeping much, and therefore this is not going to be a very smart stream and possibly a bit short. So what we're going to do is we are going to go through the code and do some refactoring to let us do the next steps a bit easier. So if I go back to my main file, the next steps are these ones. No, this is refactoring, so I can do this. I can do this. Merge the premise in chain tactics. This is, I need to do research, but I completely forgot to think about it. And this is the real thing. So the goal is to be able to support quotient, and for that, this also refactoring heavy, so we might be able to do some of it today. For that, we will consider that it is not that we don't peel off the entire refinement of the type by default. So the way we can think about it is, in goals, we don't want, like here, we can see a term, the type. This is an intrinsic type. And what we want here is a refined type, just one that is not an explicit subset. And that is, so we could have like n non-zero to n non-zero here. Whereas currently, if I do something like this, which exactly is this one actually, and yeah, it's being stripped out, and we have an assumption somewhere that if x is not, yeah, that one has been stripped out entirely, but that's not what we want, really. So this is the sort of next step that I'm looking forward for next time. And maybe we'll start today, depending on how much adrenaline and my trusted bottle of tea can carry me. No. So there was something about unification that James suggested last time, so let's start with this. Which was this? Unify zip match. No, wait, that was not the one. That was the simpler one, the one that lifted relations. That one, yeah. So what was the idea here? The idea here is that we have, something like the app of A, the app A prime, let's say B prime, and we want to say that this is this is in relation in lift R if RA B and R, and RA prime B prime. But if these are not the same, then they're not in relation at all. And what James suggested is, this is traversable. So we can do a couple of things. We can first define view shape. Yes, I'm going to just call it shape. It takes a term view of A, returns a term view of unit, but that's really void. I might have to import something. No, okay. So I don't even need to define it, but you know, just to make things a bit clearer. Okay. So the idea was that so lift relation of R of T and U, which are two terms, you start by comparing the shapes. So say shape T equals shape U and here I will need a boolean. Yeah, I'm gonna remove that so that we can use the type checker. Okay. Yeah. Oh yeah, because the relation has a slightly we'll have to be a bit more clever than this, but so we can do that manually. We won't use and. Can lift the relation in something something. Yeah, actually, this f thing is not completely well defined. I don't remember why I needed this, but I probably did. So one thing to note is that A and B is equal to if A, then B else false. Right? So we're going to expand this. If, and why are we expanding this is because we want if shape U is not shape T, we absolutely don't want to run the effect. So I want to return false, false here. And here I want to run f of bool. So I've got these two things, two lists. So what I have is I want to call something on toList T and toList U, which will be my two arguments. So that's the list of arguments. So that would be the list of these two things here. That would be the empty list here and there, the empty list there. So what I need now is a variant of zip width that, yeah, I can just zip with. It was R. It's not happy. Easy enough. Foldable as foldable. Hello. Okay. Turn Dante on. Nope. Checking that there was no mishap in the imports. No, that's fine. So now we have only a single, that is pure, not return, Okay, now I have only this. And what I can do here is I can sequence and I get an f of bool. And then I can do end. Which is not the laziest way to do this. So that means that we're going to do the effects for each of the element, even if one is true, which was what I was doing before anyway. So that should give me the exact same result as before. Fantastic. So didn't break anything that used the congruence closure. Either way, which is a good sign. Boom. Now we don't have to care about this ever again. It's done. If I change the term view, this is already correct. That's pretty nice. So I'm going to do this. I like this. There's a bit of reasoning out of the box, but any traversable will have this. I think we should just have this definition saying, oh, traversable has this, defined by default on all traversable. I don't know yet. At the very least, I can make a deriving via thing, but only if I need another one. For now, that's the one. This one is unavoidable. That's the relation between these two things. You don't have to define this. You could define a term in terms of term view. But if you do that, you will have either to call new or like roll one extra constructor over every step, or define a bunch of these as data constructors. So as pattern, no, not data constructors, as pattern synonyms, which is just not pleasant at all. An approach might be to have some like template Haskell for this. On the other hand, this gives me generic lengths of free. It's nice. It's just this one. Can I do better? Can I do something smart with this one? I have a similar thing. If the shape is not the same, they don't unify. Otherwise, you have a challenge. And what would that be? So what we're doing is we take the two lists, we zip them with right of pair, and we apply them on top of the shear. That is not that clear. Let me think for a second. We're getting into the land of having sort of binary traversals. So we can sort of abstract over this and say, what we kind of want is a function like this. It would also sort of solve this on its own. We want sort of traversable too. That's a silly name. It takes as usual, an A to FB. Doesn't really matter. Well, not an A to FB, an A to B to FC. It takes a TA and a TB, which is an FC of sorts. It doesn't quite work because there needs to be a maybe. The guess will be maybe of this. Or maybe it would be F of maybe C, which is not very different because maybe is traversable. Not sure which one is best. Doesn't make much of a difference. If you're already traversable, this is not particularly different from just having the same without something like this, without the F. We could call that app2, app maybe. We'll define it just for term view for the moment, but we can make that a bit generic. We can just ask it to be traversable, I guess. Well, that's a bit, nah. Not quite correct in general for traversable things, so I'm going to do that for term view right now. The problem with traversable things is that you don't really have a guarantee in general that two things of the same shape will have the same number of arguments. Likely you are, yeah. Yeah, actually, you are. Let me take that back. I'm pretty sure this is correct. Oh. Traversable T. App maybe. Because you have some guarantees on what toList does. Interesting. Someone's going to get bitten. It's going to be harder to do this if stackage is down, but we still have hackage, so it's fine. It's a bit less convenient to search, but we'll deal. We have F, we have T and U, let's say, silly names, and what we can do is if shape T equals shape, well shape is void in that case, void T equals void U, then something else, let's say false. Yeah, okay. I'm gonna have to bring that up. Okay, and if it isn't, we're going to say just, and we know that zipping things together makes sense, so we can do just of zip with F toList that is not false, that is nothing. Yeah, that is So you have to put them back together. So you don't want to use there's a way to do this. What's the batch type, I think? Yeah, I want to have a list and I want to just like put it back inside F. And here I have this type. we are making like way too, we're overthinking that so much. That's funny. I don't know what this is. That's probably something in batch. No. Oops. It's only here. We could also use a normal type, but it's easier to use this right now. Because using batch, the type safe version is all nice and all, but it has the defect that I don't know, like I don't know out of the top of my head how to make that work for two traversables at the same time. I'm not entirely sure I can. Therefore, I'm pouring more tea. And I'm going to use the unsafe Refactoring contents. So, and we're going to use unsafe list TA list B TB and here I can just use or actually it's not happy. Right. T. Yes. Fair enough. Okay. So I just have to do this, and I can do it by following. I have state imported. No. If I ignore the value, as it should. Oh, I see. I should, I'm going to do it a bit more elegantly then. I'm going to do that. If it's empty, then I want to say error. The number of arguments should be exactly the length of t. And otherwise BBs. And we can say do put b's return b. That's clever. Import control.monad state qualified as state. Nothing supplies. I don't know how I did this, but I did. So what's happening here? What's happening is we're traversing the structure with as an applicative the state monad, and so at every step we're ignoring the thing in the hole. That's what you're supposed to do, and we are putting the next thing. We're popping this queue or stack of things to add. And we are changing the state to be the next queue, the popped queue. So next time we'll have the second one and the third one, etc., etc. And so when we reach the empty list, it means that we didn't have enough arguments, and that triggers an error. That's why I put Haskell stat. It's an unsafe function. It's a partial function rather than an unsafe function, but that's fine. Call it unsafe. I don't really want it to be used, and we can fold things together. So here we have one maybe. We don't really need to use a different function for this. It's not going to be much simpler. But the basic story here is that if we do we do traversable 2 of something and just ignore, like it's a traversable 2 on a constant functor. We can do it if we want. And so traversable 2 can be defined in terms of this. It's probably not the fastest way, so we might want to invert things later to avoid rebuilding every time. But so traversable 2. So that's for any traversable that have a shape. Can do that FTU by saying this is map sequence A on app maybe of FTU. I don't know why it's TFU here. And applicative FEF. Boom. And therefore this is really traversable too. That was actually cool. that was nice. Of RTU. However, not yeah, okay. So we need to do compose here. It's not going to be shorter. It's just for the kicks. Compose. So compose gives us there's going compose of const. We need const. Okay. I'm liking this a lot. This is very entertaining. Very interesting too. Let's traverse too. Okay, that's... yeah, okay. So I'm not containing this package anytime soon. So where were we? Okay, we want to compose of const.r. So this will have type. Okay, it's a bit lost. Okay, so compose of const r, because r has type a to b to f of bool. Ah, no. I'm wrong. Yes, actually, so I'm gonna write that. So okay. So this has time bool, so, f of bool, sorry. So this is time f of const bool of whatever. Sorry about the background noise. If you can hear it, I don't know. So this is not supposed to be here. This is supposed to be here. This has type AB to compose something. Right, so we have compose bool of term view. That's what we have here. We have maybe of this actually. And one f of bool. So yeah, this is silly. So I have maybe, so we have to do a case of and of just b, just b. I have a boolean. It shouldn't be a bool. It should be parsing error. Oh yeah. Nothing false. We found a whole of type f of bool. what's the best way to do this? As we get compose b, that's an f. Sorry, so we can apply something here, and here we do get all dot get const. This is longer than the other. I think I can remove these parentheses. But I think I'm still going to keep this one for the sake of making traverse to the source of truth. This is both are instances of the other, because this is, you can obtain app maybe from traverse using identity. I think I really sort of want to see eventually if I can do traverse 2 without reconstructing the intermediate structure. If so, it's not needed. For instance, if we are doing a nothing or something like this. This is hilarious. So if we look at this, this if becomes the case, the end become the all here, the sequence A zip, there's the traverse 2, and the rest is pure boilerplate. Yeah. Beautiful. That's fine. TU, traverse 2. I don't even need the TNU actually. And a TU, these are the subterms. Now return right TU. I always do that, right? Try equality for everything, but these are, yeah, this is just testing for equality anyway. I wonder if that works. Is that, yeah, it's probably correct. No. No. Explain. Expect time term view to maybe term view either AB. Yes. Here it's either AA, either A. What? Well, that is very funny. Oh, maybe because we want app maybe. We don't want, I see, yeah. Nice. This type check's exactly the same. This is fantastic. Whoa. Okay, this is more interesting than I expected it to be. Zip, lift relation and zip match are instances of a generic traverse 2. Generic traverse 2 is a newly introduced generic function is define over every reversible where shapes can be checked for equality. I think I can remove the shape definition as well. It's been pushed. So that was cool. That removes some of the boilerplate we need. Is there other places that has annoying boilerplates like this? I'll just look through it. Okay. Well, that is unavoidable, I think. Maybe not. Look at this. We have a p-end. We're transforming it into a v-end everywhere, and we're doing substitution. And the substitution stays the same everywhere, I think. Yes. I think that, oh, there's this case. Okay. So it is not a mere case of substitution. No, sorry, of traversal. But I have something like this, yeah? Almost. Here I'm paying for the detailed definitions a bit. No, that's fine. We can just do this, and if it is not a variable, to uterm of subst t equals what was the it was unfix. Okay, it's view. Probably cc.view. Okay, it shouldn't be in it shouldn't be in cc. It's fine. View equal yeah. So what we want to do here is so we call cc.view t and this functor, so we can call toUterm subst usubst on all of the subterms recursively. With capital C, that's fine. I hesitated. Couldn't match time interview. Yes, that's true. I just have to call unification uterm of this, right? Good. Seems to still work. Everything's still fine. I'm just going to transform this and this. That's good. Interrupted. Ah, no. Okay. More refactoring. That's going to help a ton. We're this is real progress. Not anymore it is. Oh, here it is. Yeah, okay, that's unrelated. So we've reduced the boilerplate a ton. Reduce this to have this unfixed thing, the view. So this one is irreducible boilerplate. These are derived. So these are derived. This is defined generically on traversables. And so here this is too. This is such a short definition. It's fantastic. These are very generic as well. Where are the term folds, etc.? Maybe I can make them smaller. This is about as difficult as it ought to be. There's some improvement to do here, I think. Yeah. Veltac, that's trivial. I mean, that's boilerplate, but that's just mapping. I'm sure we've missed things. These definition of terms. Yeah, there's intern term here. Nothing I can do about this. Extern either. Oh yeah, we have some nice syntax trigger. This is incorrect, but not urgent. It's just for printing for the moment. So these are necessary boilerplate. They just link two types together that are defined similarly, but quite, which is fair. So this interning, it will like remove some syntactic sugar here. So that, say, if I have for all, generally the binders, I have for all A, B of type nat, it will just generate for all A of type nat, etc. It will also transform all binders into De Bruyn's. So there. Yeah. Term subs is another one. Yeah, this one is hard to. It's a bit special because it deals with all this. It deals with the binder logic, but the rest doesn't. Like, you know, term view assumes no binder and just doesn't go under binders. It would be pretty hard to go under binders because all these other libraries don't support it. I wrote the congruent closure, and I don't know how to do congruent closure under binder. Yeah, okay, these specializations. They probably, to be fair, they probably happen on their own. It's hard to know for sure. So when GAC compiled with -O sees, so here is the sets of requirement as far as I know them. So we apply something. Like we apply something that depends on a type class with a dictionary that is not a variable. One. And the something has an unfolding. That means it's inlineable in this module. That either means it's been defined in this module, or it's that it has an inlineable or inline pragma attached. And so if these two things hold, then a specialization is generated. So it generates a variant of the function with a different type. It's a different name as well, to be honest. So like it's going to be called, in that case it might be R-type subs of const or something like this. And it will say, oh, if I see R-type subs applied to const and the appropriate dictionary, then I can rewrite it to R-type subs const, which takes an A, etc. I think that it might very well be that this is unnecessary, to be honest, because if we define everything in the same module, they will just, all of them will specialize at least some degree. They're non-small and they're recursive, but they should still specialize, I think. I don't know. That's the sort of thing that is very, very hard to know, like without like looking inside the compile program. It doesn't matter that much. All of these, they're pretty straightforward, except the two main loops. But I can't avoid them. So we have basically two sources of boilerplate, as this one well, three sources: externing is interning, these two things, and three I said, and the view and fixing. Oh, sorry. So whenever you add something, you will add actually like 4 cases, 3 or 4, because R-type subs is not in the end. R-type, sorry, is not part of the other thing. Smart constructors, that's fine. Choo. I am pretty happy how this turned out. Push this. Yeah. Okay. Just 11. We have an hour. What can I do with this hour? I mean, we don't have an hour. Just like I think like I'm gonna split fairly early. We can do this chain premise thing because it's silly. Chain is more descriptive. So where's premise? If I remember correctly, premise and chain have the exact same definition. Actually, like I don't know myself as a consistent person as far as naming, formatting, or just like overall choices. I change my mind often about how to define a function, but these two, oh, look, there's one difference. Space here, no space here. Guys, adding premise was a silly name. I couldn't even find it after I used it. I thought it meant something else, so yes. Oh, syntax error. Oh yeah. I was using exactly once. Fantastic. I broke things. When did I break things? Shit. I'm sorry. Okay, let me try something. So they don't mean the same thing. What's the bloody difference? I thought they were identical. Not the same order of arguments. Okay. That's the difference as well. I do the sub first and the side condition second, which is a weird ordering. Okay. Okay, so we're going to use dash pop. Now everything is broken. To figure out which way. This is good. Okay. It's technically not quite a refactor, but whatever. I'm sure that if we troll through my old videos, the one where I made premise, I will make a strong argument why really the side conditions should go last. It's much better. I have no idea what that could have been, really. They were the same tag in the order of the sub goals. I like chains sub goal order better, so that's the one I kept. Okay. So the next step is to start thinking about monads. Something else that I might want to check is what is dead. Okay. That's interesting. Yeah. The entire shadowing logic is in use right now, which is worrying. Okay. Nothing conspicuous, like no. Save too much energy removing for the time being. Most of these are part of the API or ought to be. Okay, so I'll probably remove the most egregious things already. I thought there were some things left, but yeah, so monad. I want to change TCM to have an rnv2. Okay. So we want to move the entire RM into the thing. I will simplify some things in the future. I think. Oh, shadowing is here. That's just the TCM version of it. Probably don't need it anymore. I'll keep it around for a bit, but Yes, there's all a bunch of things that I had planned to do off stream, but never really found the time for. So how do we want to do this? First, I think I'm going to do new type. TCM. Okay. I'm going to call it muck TCM because I want to. Functor applicative monad. Now ask, I want to replace with other things. Right, so that's where it starts. Now I will need capability. Deriving as well, we'll see what we can do. Has reader hips. No, it's internal. I can use it. I can use a symbol. Via hopefully I can use the same combinators. So field pass name monad reader. Okay. This is going to be awkwardly of right, so now we have to do import capability that has source and reader, sorry. These are the one of the few things. Yes. Import qualified capability accessors as capability. Okay. It doesn't. Interesting. Has all the generic ones, but not the. Okay. Okay, so this is unnecessary, but. Not actually. So I have to make I am not allowed to write this. Is that it? Shit. Maybe that's just me being an idiot. Ah, good. So no instant for hip, but instance for hips. Good and type correct. I'm going to skip this one. This one is at hips. This one is at hips. This is quite fantastic. Similarly, I don't really want I don't want to, like, I could just derive minute writer, but since I'm going all the way to capability, I'm going to get rid of this and give it a name. I'm not going to make anything very smart. I'm just going to call it goal. I need to find the TCM thing again. Okay, there's an ugly line. It's fine. Why is there? Okay, async goal. Or maybe that should be another name. That it's not a goal. It's a constraint, I guess, or it's a side condition. I guess the constraint. At the end of the day, we can refactor this a bit, make a reader T of IO. Doesn't matter. I think it's state. I'm going to keep this ugly just because. So we're going to need, capability dot lift reader T yada yada capability dot monad reader. It's not what we want. So now we have for that we have a state and monad reader. No, that's not what we want. We want something from the state. So but that's not the right one. So and here, so we have a stack sync. Sync. Sync stack. Okay. Oh yeah. That's not writer, it's state. That would be goal. Ah. I'm supposed to prove that this has state, and then I do lift. I'm supposed to prove that state has a state. Oh. Right, actually I can just use monostate here. Aha! So I want to run writer, but that's just run state instead. Empty, which in that case is the empty list. So flip. Until should be yield at constraint. Wow. And so it's not one of these, it's one of these. Actually, I don't even need this. And it works. That's fantastic. Ah, I love it when it works. Okay. So all this was to give me a bit of flexibility. So you're going to see we get to define these things. So now we're going to add some fields to this. So we're going to have data, type checking context, and so type checking context is for the time being given by tc hips. It should be hips. I'm just going to use this. Hopefully, I must have duplicatable blah 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 thingy, which is fine with my setting. Hips of type list of prop. Also, I'm surprised. Something's weird. So what I expected. Oh, because when I do, I'm guessing that's. I think there should be a reverse here. Isn't that reverse? Hey, David. You're here early. It's good too, because it's been it's been a quiet night. I'm very confused. Okay. Huh. There's an A and a gold. Oh yeah. Why doesn't that work? Oh, because over. Okay. It doesn't make a difference, but it's definitely the right thing. So apparently I never generate more than one goal so far out of type checking. Otherwise one of these would be wrong, but I'm pretty sure this is the one that I want. Like if I find a later thing, then I will add it up in front. So I want to reverse the list eventually. Oops. Refactor. TCM. New type. I also took the opportunity to replace the MTL functions by capability functions. Here we go. So, as I was saying, now we want to say this, and we want to say that instead of hips here, we have TC context. Also here. Could mesh TC context with prop? Yes, because generic lens. It basically uses generic lens under the hood. So I want to add this on top of this. I may just do this actually, like field. The field is hips, and I need a null tag. So context. Chungur, if you're writing, this is not a good error message, though I'm abusing your library a bit. What is this? Not used. Oh no, that's my fault. Okay. But still, I thought you had like I thought. Oops. That I thought that generic lenses had special cases for this. Heaps equal empty. Neat. Now we can fully add more things. But the refactoring will be harder. Tell me, I want to add environment, which is of type rn. Yes. It's actually a good question. Yeah, it takes an extra argument, yeah. Oops. Sorry, let's go there again. Here we have an rn.tcma. Okay, I need another one. That's not the most essentials type. That's more interesting. In C, we have an environment that comes from top. Yeah. So we need an extra thing. No, that's interesting. Oh yeah, that's normal. Here we need an environment, and that's this one. Here I need an rn of here. Missing a capital letter. Ooh. Okay. Okay. Light check is gone. Well, anyway. Something's wrong. Okay, so I don't know exactly what happened, but that was not flight check's problem. Okay. I blamed the wrong component. Okay. So let's just mark this as a whip. Right. So here I want to remove this. And okay, now there's plenty of things. I can remove this. Wait, what? Why do I use this? Okay. I don't remember why I need this, but I can remove this in a second. Ah, yes. Couldn't. Did I provide this proof? No, I didn't indeed. Yes. Okay. What's the type Aaron for already? Or at the moment? It's named. Yeah, okay. Fair enough. Yes. All good. Okay. one is good. Can I jump to definition? No. Pity. Oh, wait, maybe I can. Right, it was built in. Okay, good, good. The file is too long. It's 1500 lines. I should probably split it. So this type in for refinement term. I can remove this ran from here. Oh. Yeah. Uh-huh. No, I don't need that. Oops. Guess I'll do that for the time being. Oops. Just for the sake of incrementality. Oh. I'm going to just remove this. And this, of course. Okay. That's good. No, what I want is TCM. It's quite remarkable. I would have expected more failures. There's a single call to local. Yeah, because I don't have a lambda. Yeah, that makes sense. Okay. To use the same style as the rest, I should use this. There's one last thing to do. And the one last thing was in run TCM. Here. Still good. Remove this. Here. 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 Still good. Remarkable. Okay. Well, that means I'm done with this refactoring, surprisingly enough. So David, you probably don't really know what happened. The concept here is a monad. Monads. This is originally called from category theory, but in computer programming, you would use them to model things that you can do. Like, I don't mean computation, like computing a value, doing addition and things like that, just manipulating values. So so-called pure computation, they're fair game everywhere, at least in this model. But other things, like things that you perform, like modifying something or reading some piece of memory, etc., etc. This can all be packaged in a monad, and a monad is a universe of effects where an effect is something that you can do. And here what I did is I abstracted more things that I was doing explicitly inside inside this monad thing, inside one universe, so that I don't get to speak about it most of the time. And I can more easily change it or vary some things about it. And so previously I had one extra argument to all of my functions. It was an environment that I was reading. And instead of that, I gave my monad a so-called reader effect. Reader is for local state. That means what you can do with a reader is you can have a look at what the current value is, or you can change it for the sake of running a particular computation. You can't really change it forever. That would be a normal state. So you change it and you can return the new value and the state has changed. The local state, you can change it for a scope, and you can't really read it out of that scope. It's very useful in programming languages because you want to add some local data. So you're entering a function, and when you're entering a function, you have all these extra variables with their types that you want to be able to talk about within the scope of type checking this function. So that's the general idea of what's happened. This environment, this extra argument, has become a reader effect. I've got other effects in that monad. One of them being a so-called, well, it's not a writer effect. It's a sync effect. I can like push some values into something, and I use this to compute like constraints that I need for something to be well typed out. And so I get at the end of my type checking algorithm or my type checking like first pass, and I'll say, yes, the term is type checked if all of these things are true. So every time I find one of these that I want to defer, I say, oh, let's check that later, which is sort of how the entire proof system is working, really. But every time I find one of these, I say, okay, I like push it as a constraint. So I've got that effect as well. Yeah, it's a slightly like it's a convenient way to structure a program that has some properties, but I don't really want to go into details. Not that this program is particularly magnificent, but yeah. It ended up being a bit more self-contained like this. Yeah, and like, yeah, that's sort of what I'm going to here. Another possible effect is to model failure. Here, when a program is not correctly typed, it will fail catastrophically. Like it will just, the program will crash because I gave it a wrong type. What I want instead is good error reporting. Then that I haven't, well, like at least like medium good. I don't have any locations yet, so there's plenty to improve. What else do I want to do? So it's midnight. I will probably stop very soon. Yeah. Yeah, let's spend a minute looking at what needs to change. So if my goal, Okay, what I'm going to do, back in master, pool, and we're back here. No, okay. So the next step somehow, let's have a look at the goals. Yeah, the next step is for some reason is somehow to have here an R type. And now everything is okay, so BP bound var should be R type here. That's the easy part. Right, but that matters. Here we're transforming. Sorry, I'm having fun because I wrote this index traversal thing mostly for fun, but it's really hard to read. Yes. No, but like I get it. So we use the named variable of the environment here, and we take the local ones and we transform them to underlying I type, which is not really what we want, but fascinating. Why did I even do this? Because here I'm losing information on the named local variables. I'm adding them to local variable. Where is local variable used? It's the bound variables. That's fair and appears here in the bound variables, which is still fair. However, my hips are not correct. If there's any hypothesis in my local variables, unless, when do I have local variables anymore? There should be an add local. Here it is. Ah, yes. Okay, so the way I see it is, it's a bit of the local variables here are just used in run TCM. So when I'm in a goal, so they always come from this I type. So really, it was not losing information because they were really implicitly all I types, which is incorrect. But that also means that here we can just remove this and not that one, not that one. Oh, these ones are more interesting. Okay, and this one, I can just do this as well. This is more interesting because this is really, really wrong. So let's, well, it may be wrong. I'm breaking something. I guess here we don't actually do anything, we just do this. I have to be very, very careful about the broins and how they're added. So here we don't need underlying I type, and here. And here neither. These were all like shitty. No, wait, that's not true. This will need to be replaced somehow, but I want to check the DB thing. Because here I need to make something. I need a new pair of things for underlying I type and constraint that work. So they won't be different types. They could be like I could use some kind of new type to check for them. We probably should. To make sure that I don't have it wrong. The other thing I want to check is db colon. So these are the list of I type, and so okay. Okay, so I think I'm going to make a new type to make sure that the types are not like wildly incorrect everywhere. So these should be cool. Oh, oh no, wait, this is an INV with DB and INV. That is not the one I was looking for, I think. Do I use INV anywhere? Oh yeah, in specific things that need INV. Yeah. Which I should put somewhere else because it's sort of irrelevant. This one was, and so this was a list of R types. If I take a DB, it's an R type. So what do I call push DB? I push it with the full type. Okay. Quite remarkable. So here we would keep full type. Okay. So somewhere near R type, where is data R type? I'm not sure I'm going to be using I type all that much. So I'm probably going to move everything I type somewhere else. Because it's sort of kind of pretty low level. Then basal type is under non-data, it's a new type. And so base type T. Anything else equals to save Mac basal type. Okay, I want a variant for constraint. Type constraint. Okay. Uh-oh. Oh, I see. That's just not the right module. Okay, I was a bit... yeah. I was scared that my computer would freeze. Okay. Top constraint. R-type. So we just are interested in R sub. Can ignore this. This is an annotation. Term equals top constraint T E. That's the term here. I noticed that I changed my conventions. What was and subst prop EP and top constraint of anything else is p-true. Okay, now I'm going to change goal again. Then we're really stopping. And instead of an R type here, I'm going to have a basal type. We'll still be using the more thingy when we add the coercion, which is probably going to basal type. Why should I be I-type? Interesting. That's the first error. Okay. So I need to restore this chunk first. Okay, so now flight check is okay, so instead of embed I type here, with what was the name of it? I need to cut this into files because it's just too slow. Embed basal type, so yes, so here we want to use base type. And here we don't want to use constraint, we want to use top constraint. That matters a lot. As this is going to change some of the proof though, so we might have problems. So similarly here, base type and top constraint. that's interesting. So bound vars, so these are basal type. I'm not sure whether I want my De Bruyne's to be basal types or intuitively I may want them to be basal. Let's do this. But I can't have a basal type because I don't have a hypothesis type for the time being. I think that I may want it differently. But right now, yeah, I split them later, okay. I see. Honestly, I'm not sure I'm doing this right, but hard type to basal type. Yeah, so here there's something wrong happening. Locals should definitely be basal types, actually. Are we using project localize? Yep. The locals, they only correspond to goal things, so they will necessarily be localized. So I think what I want to do local A equals embed local type, embed basal type. Now I don't need this anymore. So I can undo this. Ooh. Was there something before? Right. Well, that is wrong. There's certainly a bug there. So I'm doing something wrong. Oh yeah. Type check the same things. There's something really fishy about this. So yeah. Yeah, and so if while type checking this proposition, I get a goal, we'll have the wrong type. Let me make a whip of this. BS, more rigid types. We're going to push it upstream. Okay. That's all very fine and dandy. And so we want to make a counterexample, something that fails. So it needs I don't even remember why this one exists. I'll think about it in a long time. was a typo. I don't know why. I have negation defined, yeah? Yeah. Oh, yes. Habit. Actually, this was properly handled. Fascinating. I don't know why yet, but fascinating. Which is the DBs are actually Basel types. So I enter the thing, I've got the De Bruyne, and that's all, and yeah. So there's no bug, but I don't know why. When I type check it for all, I just push DB and type check proposition P. An abstractor of this, of course, pushing the hypothesis and the DB separately. It's very interesting. When we're doing this is f of n, so n has the DB type thing. We do f, decompose the type, the arrow type of f, that's easy. And then we have to check that n has type thing. Okay, so really I would need something that is not yeah. Okay, so check the DB has this, and because it has and when the var is used, there are some things to change here as well. This is interesting, the way I did this. It does work, I think. It's a bit of a miracle, though. It's hard to prove. Anyway, I think that's it for me for today. So yes, that's pretty much it for me. So I'm going to cut stream, and until next time, don't forget to stay curious.